Okay, so today we're going to have a look at congruency. Now, congruency is all about proving that triangles, or generally shapes, are the same, right? For us specifically, it's about triangles. Now, a couple of things quickly just to get out the way. Two figures are congruent if they have exactly the same shape and size, right? So congruent shapes only differ in position, right? And we can test that by moving them around, flipping them, rotating them to see if they lie on top of each other, are they going to be exactly the same? And now an important one is this is the symbol we use for congruency. Equal sign shows things are the same. This three sort of equal sign, mix of an equal sign, shows us that shapes are the same, right? And that is my symbol for congruency. But the reality is it also means the same. Just like an equal sign means things are equal, here congruent symbol means shapes are the same. Right. And so this is how we write congruency statements. Triangle ABC is congruent to triangle DEF. Right? Very, very important. The next important thing is basically the order of our letters. So how we write A, B, and C is very important. Whether we write CBA or BAC is important. And the reason it's important is because each part shows that things correspond to each other. So in this case, A corresponds to D, B corresponds to E, and C corresponds to F, meaning that those angles are the same, right? So the order in how we write it doesn't matter, A, B, C, B, A, C, but we have to make sure that the information is matching, right? So it's the order of the information that is important. So in this case, wherever B is, if B is first, then E must be first. If B is last, then E must be last. And that is the important part about that setup. Okay, from here, there are four ways in which we can prove congruency. The first one is quite clearly side, side, side. So this side is equal to that one. This one is equal to that one, and this length here is equal to, so the different parts of the two triangles are the same, right? The next one that we have is side, angle, side, right? So, and it can be anywhere in our triangle as long as we have the same. Now, this is an important one, put a little star there. My angle, side, must be this included angle. It must be between my two given sides, right? That is a very, very important one. The next one is a different version, angle, side, angle. So that means if I have this angle, I have this side. And actually, it doesn't really matter. This one is a nice one. As long as you've got two angles plus one side, they are always going to be congruent, right? And the last one is our right angle hypotenuse side. So don't think that is right angle or right hand side. These are three separate things. The right angle, which is here, must be present in both triangles. The hypotenuse must be given as being the same, and one of the sides must be the same. And the reason these are going to be congruent is because of our idea of Pythag, right? So Pythagoras allows us to find out lengths of sides in a triangle as long as it's a right angle triangle. And so we use that basis to prove that these two shapes are going to be the same, right? So we have side, 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 angle, side, angle, side, angle, and right angle, hypotenuse, side, right? Those are the four rules or the four things that we look for. So writing a formal proof of congruency is very important. We always need at least three reasons. If we can find more, that's beautiful, but we need a minimum of three. Anything less and we can't prove congruency, right? We use these four ways to prove congruency, which we've just looked at: side, 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 angle, side, angle, side, angle, side, and RHS, right? Once three reasons have been identified, we always end with the congruency statement, and the congruency statement is this bad boy here in the block. showing which two triangles are congruent, right? So triangle ABC is congruent to triangle DEF. Remember that the order in which we write these is important. So this is telling me that A matches with D, B matches with E, and C must match with F. So those are my angles. Those angles become the same, right? And whatever reason I've used to get to that point. Okay. So how we set this up is called a two-column setup, right? Very easy. On the left side, we have the statement, what do I know? And on the right side, we have the reason, how do I know it? Right, so this is always going to be the what, and this is always going to be the how. And it's actually really, really easy. Here are my three statements to say those are the three things I know, and I'm always going to end off with the congruency reason. All right, so let's have a look at an example. A little bit of a difficult one to jump straight into, but shouldn't be too bad. So the first thing we can see, hopefully, let's use the given information always. So we're going to say here that depending on how you want to write it, we can write QRT is equal to QTS, knowing that those two angles, my angle R and my angle T, are the same. And how do I know that? Quite simply because it's been given to me, right? So that's the first one. The second one is this little angle down here, right? So I know that in this case, let's go with RSQ must be the same as TQS. And once again, that has been given to me, right? Now we need to say, okay, I've got an angle and I've got an angle. So the only other thing I need now is a side. And I haven't been given any information about a side, but what I can hopefully notice is this side here, QS, is actually common to both triangles. So we're going to write here QS is equal to QS. And how do we know they're the same? Well, because it's a common side. And that is my side. And so now I can say, therefore, triangle. Now, the first one doesn't really matter. QRS is congruent to triangle. Now we've got to match. We've got to say, okay, if we look at our information, Q, do I know anything about Q? Well, let's look at the information. I know that R must match with T. So T's got to be in the middle of my information. And I know over here that S must match with Q, right? And I know that QS is going to be QS. So the reality is we want to say here that you can also think about how you write it as an order in which you're looking for things. So we've gone for QRS. So I've gone from the empty angle up to the double angle and down to the other given angle. So this one is likely going to be STQ. And my reason here is angle, angle, side. And there we have it. We've just proved that these two triangles are congruent. And what we know about this now, which is an important thing, is we know that angle Q is equal to angle S. We know that angle R is equal to angle T. We know that angle S, obviously, again, is equal to angle Q. We also know that the line of the triangle QR is equal to ST. We know that RS is equal to TQ. And the last one is the QS is equal to SQ, which is my common line. So you can see that I can take all of this information. So let's just go with QR is the same as ST. We know that RS is the same as TQ. And we know that QS is the same as SQ. And that is all the information I can take from this congruency statement, right? So we can say that congruent triangles have congruent parts. That means that all those parts that match up from my statement up here is going to mean that those things are the same. They're congruent. They're equal in length or equal in size. Let's have a look at another one. Now, my advice, don't get caught just because you see a right angle to think we're going to do RHS. It doesn't always happen like that. So let's have a look. What do we know? The first thing we know is that angle A is equal to angle D, right? How do I know? It's been given. The other bit of given information, I know that BC is equal to CE, right? So these two are the same. So now that I've got two bits of information, I possibly need a third, right? And so let's just see, this is an angle and this is a side. So my options are, we can go side, 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 angle, side, angle, or RHS. Now, I've already got one angle, so this side, 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 possibly out. So either I can now find another angle or another side. And what's nice is, if you know your geometry, I know that those two are going to be the same. So let's just label that C1 is equal to C2. How do I know those are the same? Because those are vertically opposite angles, right? We're happy with that. I can also say, just as a matter of extra information, that angle B is going to be equal to angle E. And the reason I know that is because of interior angles of my triangle. They always add up to 180. And if I know two of them, the third is always going to be the same. And so we can finish off our statement that triangle, which one did they ask us to prove up here, is ABC is congruent. So now let's check. You might be lucky in the questioning that they've already told you which ones are the same. So we know that A must be like D. So we're going to write a triangle D. We know that BC. So let's label our triangle. We said ABC. So down the right angle and across the common arm. We'll do the same thing in the other triangle. We go up from the 90-degree and down the common arm. So that's going to have to be D, E, C. And here we can see quite clearly this is going to be, our reason here is angle, side, angle. No, not angle, side, angle, sorry. It is going to be angle, angle, side. Now the order of this really doesn't matter. We could have said side, angle, angle, or we could have also said angle, side, angle. All of those three things mean exactly the same thing. But the order in which I write that statement is what is important. All right, moving on. Right, we are going to look at one more example. So let's see, this one is quite nice. We're going to now have to set up our own two column here. So we're going to say our statement is AB is going to be equal to CD. It's been given. We know that AO has got to be the same as OD. It's also been given. And we know that BO is got to be the same as CO. It's also been given. And just for good luck, we can also actually say that angle O1 is equal to O2. And we know that because of vert-op angles. So now we've got side, 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 and a little angle. So these two are definitely going to be congruent. And so we can say, therefore, let's write a nice therefore, right? So we're going to say, therefore, triangle ABO is congruent to triangle. Now remember, this is when the labeling is important. So ABO along the single line to the center over the three lines. So it's got to go in that order. So this is going to have to be from D to C to O. And my reason can be any of the following: side, 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 or side, angle, side. And there we have it. That is congruency, and that is what we are looking to do